Okay, this is the second video in the playlist that deals with calculating a delta H of reaction using bond energies. All right, and we're going to do a little bit more complex problem in this example. And like I said in the first video, what I prefer to do in these before I do anything else is draw the Lewis formulas for the compounds. And what this allows you to see then is it allows you to see exactly the bonds that exist in the molecule. And this is important because using this method, where it's easy to go wrong is by calculating the wrong number of a certain type of bond. And in the case of generating the Lewis formulas, it makes it a lot less likely that you're going to make an error like that. All right, so this would be this molecule, which happens to be ethanol. And then the oxygen is going to be O double bond O. I think I'm just going to leave the electrons out in the interest of time on this. And then the carbon dioxide is going to be this. So you can see in carbon dioxide there's going to be 2 C double bond O's, and then the water molecule there's going to be three total molecules, but there's 6 HO bonds. There's 6 HOs. And here there's going to be 4 O double bond C's. Here, I'm just going to rewrite it. We're going to just have 3 O double bond O's. Now, on this molecule, you can see you're going to have 1, 2, 3, 4. You're going to have 5 CH or HC bonds. You're going to have 1 CC bond. That's this guy. You're going to have 1 C bond O. That's this guy. And we're going to have 1 C, we're going to have 1 OH bond. That would be this one. All right, now for simplicity, what I've done is I've put the bond energies for each of these down on the lower part of the screen. So remember that delta H using bond energies is going to be equal to delta H of the reaction. It's going to be equal to the sum of the bonds broken, okay, minus the sum of the bonds formed. And it's necessary to realize that all bonds that are broken are endothermic. You have to put energy in to break a bond. And anytime two atoms form a bond, energy is going to be released. That's the reason for this equation. And you need to pay attention to this because the equation for delta H not using delta H formations is different than this. All right, so let's start to put this together. So we're going to be solving for the delta H of the reaction. And we're going to have 5 CH bonds, so it's going to be 5 times 414 kilojoules. I'm just going to leave the unit out, again, for simplicity here. And then this is going to be added to, we have 1 CC bond, so it's going to be 347. I'm going to check these off as I go. All right, I'm going to have 1 C oxygen bond. That's going to be this guy, so 360 kilojoules. All right, and I'm going to have 1 OH bond. And the HOs are here, so it'll be plus 464. All right, and I don't want to forget my oxygen. We're going to have 3 O double bond O's, so that's going to be times 498. Okay, and let me check that one off. So we should have everybody here, and when these are summed together, the total is going to be 4,735, and I'll put my units back now. It's going to be kilojoules. That's the amount of energy required to break all the bonds that we need to break. All right. Now we'll go ahead and start subtracting. So minus. Now we'll deal with the other side. So we're going to have 4 O double bond C's. So that's going to be 4 times. Actually, let's do it this way. Okay, so in reality, yeah, let's do it this way. There's so much of a calculation. This is going to be sums of bonds broken. Let's just do it that way. All right, and what we're going to calculate next is going to be the sum of bonds formed. Okay, now, so we're going to have a total of 4 O double bond C's for the carbon dioxide. So that's going to be 4 times 799. And that's going to be added to 6 HO bonds, which is going to be 464, for a grand total of 5,980 kilojoules. Now we'll do our subtraction. So the delta H of my reaction is going to be equal to the bonds broken, 4,735, minus the bonds formed, 5,980. All right, and this is going to equal a negative 1,245 kilojoules. So this is an exothermic reaction. It's an oxidation. It's actually a combustion. And I'm gonna go ahead and label these for clarity. So this was bonds broken. This number was bonds formed. All right, and this is the delta H of the reaction.